Okay, so we just finished our module on RCx Scoping, which is focused on how to approach an initial RCx assessment and how to look for key indicators of performance in our mechanical rooms. Now we're moving on to system diagramming, which is a skill that focuses on recognizing the key configurations in our HVAC systems. In many ways, these are complementary skills. We need to be able to untangle our piping and ducted HVAC systems in order to scope them, and in scoping them, we may find issues or opportunities with their configuration. We can also call this skill system thinking, in that it's a broad skill that supports more than just RCx fieldwork and is something we laid the groundwork for in our HVAC fundamental sessions when we indicated that our building systems were really a system of systems, highly interconnected and often complex. So we need special tools to assess these complex systems, and system diagramming is one of these tools. Take, for instance, this simplified flow diagram from a recent Army project. I say simplified because this drawing was meant to be a clear illustration of hydronic system configurations. However, the complexities were still evident and somewhat muddled the ability to be able to evaluate if the system was really going to deliver the performance that was intended. Here's the closed loop portion of that same diagram. However, here we've rearranged the system to highlight configuration types that better hint at how the system will perform. A number of deficiencies were found once the system was unraveled in this way. And using this tool, communication with project design staff was easier and led to prompt correction of issues found. However, even in simpler setups, the system diagram can be a valuable tool. Take this basic primary-secondary system. Poor bypass and throttle distribution pumps were discovered, but using the system diagram, the RCx team was able to point out that based on supply temperature set points, the valve type at the load, and the GPM requirements for both the load and the plant, the system could not just be repaired, but improved to a more suitable primary-only configuration. But even if no configuration issues exist, the system diagram can help in identifying exactly where in the system you may want to collect performance data as part of a detailed monitoring plan. More on those in the next session on trends. So whether you're looking at water or airside systems, whether you're trying to understand a system in the field or a system on paper, a system diagram can aid in the process. It's really a tool that pays dividends in a number of facility management applications. We've compiled a set of common HVAC symbols to make your own system diagrams, but really any convention is fine so long as it's consistent and understandable to others. So what does this process look like? Well, you would first pick a place along the distribution to get started. Typically, it's helpful to use major equipment as your first landmark, like with this chiller. Next, track piping or ductwork distribution to and from that equipment and make sure to capture things like control valve and damper arrangements, other equipment or load devices, and tees or branches. Elbows and other fittings may be important from a pressure standpoint, but for system diagram purposes, unless there's a special reason to represent them, only fittings that represent the order of connection between components are typically shown. You may have to track down how distribution penetrates through spaces and into walls or chases, possibly pacing out where runs should be emerging from roof, basement, or mechanical areas. But finally, once all loads, load management equipment, control components, and connections are flushed out, you can create an untangled copy to evaluate or share, like this one. So you may start with a couple versions of some sloppy field notes, and then you take that back to the office and you create something like this digital copy that is a little bit more manageable to look at. So there are other rules of thumb and techniques to consider, and to walk us through in the next video, David is going to revisit the central plant with some changes and show us the system diagram process and how it works. But also follow the link in the comments to check out his blog where he details lots of these system diagram techniques and examples. Thanks for watching.